Okay, for the recording, welcome team for another exciting session of the data engineering. Yes, go ahead, Sai. So we're just checking how the team is feeling about the training and the data engineering and Databricks specifically.
I said since I have some SQL background for many years, I've been working on SQL.
mm,
I don't see it as too complex, but I just have to practice the PySpark commands, like all this, how to import the libraries and how to use the proper commands to
okay.
pull the data and transform.
Okay. Who's Pandu some joined?
Pandit Narana. I'm here, Narana.
Hey, Narayana.
Yeah,
Change the
this is
name.
my professional name. Yeah.
Okay. All right. So, Murali Subbu, how are you feeling about this?
Yeah, it's good, Arun. So yeah, as I said, because I have been working for these SQLs and kind of data migration projects, and I know the concepts of this ETL as well,
Right,
Informatica
right.
and data stage. So the only thing is the new architecture-wise and the commands, especially the PySpark commands,
Mhm.
we need more practice, and also we need to see the overall project how it goes. So as you said, we can discuss that one at the end of the sessions. I mean, end of this course. So yeah, we'll get some ideas of how we can present ourselves. We are a data engineer, something like that, right?
Yeah, sure. Uh,
Coming to me, I have also like SQL experience and database experience as well as application level experience. So how to migrate database to application level. So that's why this Databricks, so I can understand easily. And you were how you explaining the technical things is very easily understanding for me. For example, batch jobs or streaming jobs or DLT jobs. I think overall end of the course, I already did it, but second time it's more understanding for me. I think I hope it will be getting job quickly, I feel.
right. Awesome. Great. Yeah, that's the confidence. Very nice. So Shanmuga and Vikas, how do you feel?
So,
I know it looks a little
yes,
complex at the beginning, but as we said, you are at the entry level, right? So expectations are also not like industry experience 10 years or 15 years, but you are at starting. This is a very good opportunity for you guys. So how do you feel?
right. So, prior to this class, I knew a bit of Python, I knew a bit of SQL, but all my knowledge was bits and pieces. There was no tool, no technology that I was sure that I can do a project in. But throughout the class, I've been learning, and then now I can say that I know, I can do a few ETL jobs. I know that I can learn Databricks. I can have Databricks as a career.
Yep.
All that confidence thanks to the class and everything you taught.
Awesome. Great. Okay. Yeah. So if you look at what we have been, covering, right, uncovering in this training session based on these modules, we have done the most foundation, basic practice, everything. So foundation, batch processing, structure streaming. So we did Delta Live tables, right? Acid storage, Delta Lake. What is Delta Lake and how it stores and all of that, correct? Scheduling and workflows. Part of it comes with the live tables, and the rest it's just like how you schedule. We will just touch up on that later. So module 6 we have to cover a little bit, and module 8 where we talk about what is Hive Metastore, what is Unity Catalog, what is DB-SQL and all of that. So today we will so these two we will cover in next week, whatever is pending topics, all of them next week, and the week after that will be the last two modules. So you guys be prepared for these two, module 9 and 10. Specifically, I will discuss 9. 10 is actually you can practice and prepare for demos. Okay, you can give some demos and then we will talk about practice about some certification the week after next. So this week we will talk about the distributed computing module 5. And there are some important concepts, Spark internals, as we said, these are some little advanced topics. And then next week, as I said, we will cover this scheduling workflows a little bit, touch upon that. There's nothing much to practice or build or anything. It's just a concept, how you schedule your jobs and what are the workflows. And then we will talk about the Unity Catalog, Metastore, and DB SQL, these two topics. Okay. Anything else you think we missed in this? We've been talking about all of these, right? And if you feel like if there is something, we will definitely cover next in the coming classes. Okay. Now, we'll talk about distributed computing internals. Okay. So I will have I will open a Excel as well. Okay. Now, how many of you understand what is distributed computing? There are two concepts, like cloud computing and distributed computing. Can anybody talk about what is cloud computing? What is distributed computing? Anybody? Subbu? Hey, Venkat, welcome.
Thank you, Arun.
Subbu,
Distributed computing means whatever the data is coming, so large data, it should be distributed to the clusters and execute the queries.
okay. Clusters. Okay, there's something interesting. Clusters. Okay. So Subbu is saying distribute to the clusters and compute. Okay. Anybody else? Sai, cloud computing, distributed computing.
So I may be wrong, but maybe
No,
cloud
no, that's fine. Just give it a shot.
like let's say distributed computing is like after cloud computing is basically you computing not in your resource like in your laptop, but like outsourcing the computation process to some other server. And distributed computing is like next level that enhanced the cloud computing, fastened the cloud computing. It outsourced the computing to outside, but the computing is done in different servers, like different nodes and machines, so that the workload is shared and the work is done faster.
Yep.
That's what I think it is.
Great. Yeah, you're close. You're close.
Like processors and memory and storage are spread out and work together as a single. It works as a single system, right? That way, I feel that this is the distributed computing.
Okay. Okay. Processing, memory, working together. Okay.
Storage, yeah.
Storage. Okay. Storage. All right.
Work together as a single system and basically like enabling the large and more scalable and faster processing than single machine could. This is the
Okay. Nice. Yeah. Yeah. Good. Okay. Let's take an example, right? Just think about it. So in in our days, olden days, like many years ago, we had this whatever. Right now we are getting all processed foods, right? Packets. But I think most of us, in our childhood or maybe 25, 30 years ago, we didn't have all of these machines at home, right? So what we used to do, if you want rice flour, wheat flour, chili powder, remember anybody carrying those from home to some place where they have big machines? They process it for you and they give you and you pay. And also
Yes.
the
I
wet
know.
in at home, if you want to make idli, dosa or whatever, those days you used to take your rice and whatever, all those pulses to the shop. They have a big grinder and they make you the batter and then they charge you, right? So that's how we used to do 25, 30 years ago.
Mill machines,
Machines,
milling
yes.
machine. Yeah.
Machines, yeah, absolutely. There's a wet and then dry, both separate. Dry is for like powders, flours. If you need rice flour or wheat flour or something, and chili powders and other stuff. Jawar flour. People who are like in Rayalaseema and Bangalore, they do more, Karnataka, more jawar for rotis, right? So they also go and get that done in the mill and get the flours. So basically, that is the process. Right now, we have come a long way. It's inverse. Now, all the machines, portable grinders, mixers are in everybody home. So we don't go anywhere. We make ourselves. And plus, we get everything processed in packets right now. So all flours you can just go on off the shelf buy. So basically, it's the inverse of what we're talking about, right? So if you have everything in house, I have a mixer, I have a grinder, I do it, I use it, and then that is in house. I'm processing. But if I go out, get it done, right? So that you pay as a service just once, because you are not doing every time. You don't want to have that at home, maintenance, repairs, and everything. So, right. So if there is something at the milling machine, if the machine is repaired, he will take care of his machine repair and maintenance and everything. He's just charging you for what you see. So it's a similar concept. So cloud computing is you're not even not at home, even the enterprise. When it started, every company used to have their own servers, their own data servers, their own processing servers, RAMs. They used to order. They have a server room, somebody maintaining the server room, network, admin, everything. Every organization had to have that, go through it. A networking team and server maintenance and all of that. They have to plan capacities, uptime, downtime, maintenance, adding more servers, and all of that. Space was all also constraint. Now, what we are doing, that is all complexity is gone. You just use the servers somewhere. We like you infrastructure as a service. So that's all infrastructure, right? So now we have big service providers, infrastructure providers, Amazon, Google, or anybody who's having those machines, just like servers. They have big data centers, data farms, or machines, which you can just use it whenever you need. Do the computing and then pay for it. So, which is like that's what you call cloud computing, where you don't have anything on-prem. You are just outsourcing or just using the service which is there on the cloud. So that is cloud computing, right? Any doubts, questions, anything you want to add? Which is basically like servers which are on the cloud, when they say on the internet or the network. Somebody is providing you, you take those and then you kind of use it. So similarly, you have concepts that's like IaaS, that is like infrastructure as service. You have PaaS, platform as service. You have SaaS, software as service. Everything is like, use the service. You get that, use it, and pay for what you use. Now, coming to distributed computing. So in cloud computing, like whatever cluster you're talking about, you are creating that compute cluster. So that's all on the cloud, right? You are not using any of your resources. So that is your cloud computing. So what is distributed computing? So let's say I have this an elements. So just say I have few elements, okay? Okay, before going to the elements, let's talk about the normal example. Now, so the task I have is to collect information from, say, a village. Okay, or like statistics. How many people are there? How many houses are there? How many people live there? What is their income group? And all of that information. Now, what is the process? So I have, let's say, 3 people. I have formed a team to go and get the information. So what is the process?
So basically, they will divide each how to do.
No, we'll come to that. Now, let's say we have a team. The team is all 3 of them going. So what is the process to take the statistics? First, they go home to home, door to door, right?
Yes.
Gather information.
Yeah. So let's say there are 100 homes. Okay. And I'm saying to collect information from each home, how much time it will take? Example, let's say
5 minutes.
Okay, 5 minutes. So 100 homes, 5 minutes. They're going in from door to door. How much total time it will take?
500 minutes.
Like 500 minutes, they get all the information. Now, as somebody Shanmuga was suggesting, I want to split this team. Why I want to split this team? I want to take advantage that they can do more, each of them, right? All 3 of them, I don't need at the same place. So let's say I have 10 streets, right? And what I will do for 3 people, 1, 2, 3. So I will say first person, you take 3 streets. Street 1, street 2, street 3. Okay, whatever it is. Okay, so this is again, say 4, 5, 6, and this doing 7, 8, 9, 10. Okay, let's say 4, street 4, 5, 6, 7, 8, 9, and 10. Okay. Now, say first 3 streets have, let's say, out of 100 homes. So they have 30 homes. They have 30 homes. I'm just assuming they all have 10 homes on each street. Okay. Very ideal village kind of plan. Now, the first one is going into first street, door by door, taking information, then going to street 2, then going to street 3. So he will cover all 30. I'm still saying it will take 5 minutes. If 3 people ask the questions, 1 person asks the question, is the same thing, right?
Yes.
Are you with me? Yes. Okay.
Yeah.
So
So
how much time first person will take to complete 30 homes?
150.
So 150 minutes.
Same
Now,
time.
Same time.
Same time.
There are 40. So let's say this will take 200. Okay.
Yes.
So total is still 500 minutes, correct?
No, but It's same time
Yeah.
everybody is doing this. So total 200 minutes they
Exactly.
will
So
complete.
let's say they all start at 10 a.m. Okay. And then they are working without break. Now 500 minutes. It's like roughly 6 hours and 20 minutes, right? So they will finish at say 4:20 p.m. Correct? Is this right? Guys, are you with me?
Oh yes, SRN.
Because Shanmuga,
Yes, sir.
Yes, sir.
okay, this is right, right? Now, again, let's say we do this, follow this process, and then they start 10 a.m. What time do they finish?
2.5 hours, like 12:30.
Yeah.
First
This
one is 12:30,
person,
second one is
first
12:30.
person, yeah, first person, it's like 150. So it's like 2.5 hours. So in about 12:30, this person finishes. This person also started at 10. So this person finished at 12:30. Now this person has more number of homes to cover. So 200 minutes. So it's like 3 hours, 20 minutes, right? So he will
120.
finish at 120. Now, once these three guys are done, now each one has information of some homes, 30, 30, 40 homes. All you need to do is just combine all three, right? Let's say they are all combining and then they take another 10 minutes to combine all that data. So by 1:30 p.m., they are done.
Yes.
Now, here they are doing it 4:20. Now, here they are done by 1:30. The total time is same, but now we are doing in parallel. We don't want to go sequential. Each person is doing the same job. So they might as well go and do it differently, parallelly on each of those homes. Now you have done the same amount of time overall, but you have finished faster, right? So now here you have done by 1:30, but here you have to do until 4:20. This is in a nutshell distributed processing. This is your data. Okay. 100 homes, let's say you want to have 100 records you want to process. And these are your machines. If you want to run all on 100 on one machine, it has to go sequentially. Okay. Now, if I have three different machines, not just one big machine having three processors or whatever, if I split it, I use three machines, even if they're smaller. And then I divide this work, 100 records, into these three machines. Now, these machines are individually doing. Each machine is doing on 30 records. This machine is doing 30 records. This machine is doing 40 records. Then you merge all that information and then you come here. So total time is done, elapsed time, you call it. Elapsed time is 200 minutes. So the time taken to complete the process is the most elapsed time is the time taken by the longest machine, whichever is having the highest, taking the longest time. These will finish and wait until this completes. Once this is all of them are complete, you combine the information and you are done. Understood?
Yes, sir.
Easy,
Yes.
right? Now, let's take the same concept and apply. Say I have a task to say a function. I want to apply a function. So I have, say, let's, I'm coming back to this. I have elements, okay, some elements. Okay, so these are all the elements. Now I want to say multiply by 2. Just want to do, okay, straight, simple, right? We are writing a for loop, iterating through each of the elements, multiplying it, and then storing it. So here, first I will go do 2, 6, then it comes 10, 16, 18, 12, 0, 24. This is the process. This is sequential process. Now what I want to do, I want to do parallel processing, distributed processing. So how will I do that? I will split these into different chunks, right? Partitions. I call this partitions. So I partition the data into say 3 chunks. It may not be sequential. Okay, so don't get this. You can get 3, you can get 0. What are we missing? 5, 9, 6. Okay, 6. Let's add one more. 50. Okay. So what is this partition? Guys, I want you to participate. This is the fundamental concepts. We are revisiting, going back to the drawing board. Ideally, any training, people start here. Okay. And then they start going, adding this chapter by chapter. But we do differently. Now you have very good understanding of data pipelines, ETL, batch, DLT, everything. Now coming back to the basics, how it is actually working under the hood. Now you get a pretty good sense. Now you don't get overwhelmed by what we are, starting to see some complex things, because you already know how it works on the outside. Now we are digging deeper into under the hood what is happening, right? So I want you to participate and let me know the simple concepts. Come on, what is this partition?
So it's basically a parallel processing.
Yeah, so let's call
Yeah.
this one partition. What is the name of this partition? We call it A.
Yeah.
Okay.
B, partition B.
This is partition B.
Yeah.
This is partition
C.
C. No, sorry. Okay. Now, let's say the function is same. I want to apply. Now I have partitioned the data. Now let's say I want to move this data or have this data on different machines, not on one machine. Split it. Okay. So now this becomes machine 1, machine 2, and machine 3. Again, don't get fixed on what you see here. Partition A is on machine 1. It can be on any machine. First thing. Any partition can be on any machine. First thing. Second, multiple partitions can be on the same machine. These two things you have to fundamentally understand. Don't get fixed. One machine, one partition. Partition 1 is always on machine 1. Okay. You have to remove these things right when you are starting learning, because once you learn like this, unlearning this will be difficult. That's why I'm saying. So this can be 3. This can be 1. This can be 2. Okay. And as I said, there can be 2 partitions here within machine 3. We'll come to that. Now what I'm doing, multiply by 2 function, instead of doing on one machine, say driver. So I call this driver machine. Okay. And now I call these worker machines, because now I am asking these workers to do the work for me. I will only drive. Now I am the manager. I will just assign the tasks to you. You do the work and give it to me. I will monitor. I will assign. I will check whether you are doing properly or not. I will take back all your information and then report. Now you are the team members, workers. So driver, worker. Got it?
Yes, sir. Yeah.
Absolute. Amazing.
Yes.
Okay. Now what I do, I take this function and I send it to all the workers. Okay. Guys, this is what you need to do. The data is there and this is the task. Go and do this task on your data. Fine. What I'll do this, the driver will send all this data. Driver will, so its partitions are already there. So driver will send, this is the task you have to do on whatever data you have available for you at your place. Now I go here, this worker, machine 3, say take this. Okay, I have this data with me. I will do this multiplication. So it will become 2, 4, 0. I'm done. And it will go back to driver and say, hey, I'm done. The data is here. Okay. Let's check how is worker 2 doing. So worker 2 says, yes, 16, 24, 6. Yes, boss, I'm done. Now let's say go see. I still cannot say the job is done because I don't have all the information, right? I'm still waiting on machine 2. So he's saying, boss, I have more work to do. I've got more information, more data here. So I'm still working on it. Okay, 10, 18, I'm almost there. Okay, now I'm done. Now the driver will see, okay, all the machines are done. The job is done. Now let's take all this information. So these are 3 bits and 3 sets of data right now. So what I will do, I will go here and then combine everything from all 3 workers and get the data and give you, okay, you gave me this data. I finished processing. This is the output. You take it. Right? This is the driver. I'm collecting the information from workers. Whenever you say collect, always think all the data is coming from machines to the driver. Everything is coming on to the driver. Collect. So this is the information. Now this is same as here, but we have achieved the distributed computing or parallel processing. Okay. Done. Now I'm collecting here, which means that I'm getting everything data again onto the driver and connecting. And say if I have to send this or write it to the database, I will just go and then write again row by row here. Let's say database. I'm just adding each layer here. And then we will see how we are arriving on what we are doing. So if I have a database, what will I do here from the driver? How will I write?
We will write in store.
Yeah, I will write in sequence, right? Again, 2,
Yeah.
4, 5, 0, 16. Again, coming back to the same thing. I have achieved the parallel processing, done the distributed computing. I've fastened the process, but when I'm writing it, again, I'm collecting everything and writing it. Now think smarter. Anyway, everything is going into the database. I have 3 pieces. Why do I collect all 3 and then write again one by one? Can I not directly go and write from here? So I write this piece and then I will write, this machine will write this piece, this machine will write this, whatever they have done, completed the information, let them write from there, right? End of the day, everything will end up in the database, correct?
Yes, sir. Yeah.
So this is what you are doing when you are writing from the Spark dot write. When you say data frame dot write, data frame has partitions. Though it looks like one data frame, though it looks like this, okay, though it looks like this data frame, the underlying this information is spread across multiple machines. The processing is happening on each of the machine individually. Each of the machine or the nodes have their own part of the data computed and ready. when you write, you can choose to write each partition. So each partition that you are writing will become a file. When you look at, you have seen, right? When you've seen dbutils.fs.ls and then you give the path to the table, you see number of files. You don't see just one file, dot part. Remember? How is that part coming? It is coming from here. Each partition you write will go into one file. Right? This is how the files are being written into the DBFS. Guys, got it?
Yes, sir. Yeah.
Yes, sir.
Yes, sir. Yeah.
Understand? Concept simple?
Yeah.
Okay. So now this is exactly what Apache Spark is doing. Distributed computing. That's all there is to it. Now look at this. This is what is happening. This is what I just explained. This looks complex, right? But if you break it down, this is exactly what we discussed right now. What is the input? We have multiple words. What I want to do, task, I want to count how many words are there. What is the count of how many times each word is repeating? Correct? What I do, I split this information. So what are these called? What did we just talk about?
Parallel
Partitions.
Partitions, yes. Partitions and, okay, we're doing parallel processing. We split into 3 partitions. Within the partition, I am asking, hey, do the count. So this is the old, actually the algorithm that we use called map reduce. Okay. So we map what we say. Okay, deer, we will say there is 1, bear, there is 1, river, there is 1, car, there is 1, and car, there is again 1. So I'm just assigning a number to each of it. Then what I will do, I can sum here. I can say deer 1, bear 1, river 1. Here I can do car 2, river 1, deer 1, bear 1, something like that. But when I send it again, the deer is here, the deer is here. Again, I have to count, right? After counting internally. So the example we said was because these are all independent. But now there is a dependency. I have to count deer here, deer here. When they come next stage, so I have to say deer is 2. So to do that, what we do something called shuffling. What is a shuffling? Shuffling means we get similar data into one partitions, one machine. So basically I take, first I will say deer will go to machine 1, all deers. So deer from here will go, bear from here, become one partition. Car, all become here in this partition, in this machine. So I have identified and split based on the data and shuffled data across. Now all data is same. All I have to do is count here, bear 1, 2. This is reducing. So bear is 2, car 1, 2, 3, deer 2, river 2. Final result, I will collect all of this. Now I know bear is 2, car is 3, deer is 2, river is 2. This is the entire map reduce process with shuffling. So in this entire picture, what looks complex? Shuffle, right? So when you're doing the shuffling, that is the major task that will take resources like your memory, disk space, memory space, disk space, network IO, because the data is moving around. You're grouping the data. Okay, so this I want deer, right? So it can be on any machines. So I have to go and check which machine has deer. All the deers come onto one machine. All the cars get into one machine. So this is a lot of shuffling. This is going here. This is going here. This is going here, right? So you remember when we used to do some games, everybody gets a common number. Then finally we'll say whoever got 1, come and stand on the left side. Number 2, come on the right side. So that's how you used to form groups to play any games, right? So same thing. They have all these tokens. How do they identify? There will be a key. So you say whoever having the same value come here. So this shuffling is what is the complex task in all of this. And this is where most of the network IO, your what you call processing and elapsed time, all of this takes place. So anytime you want to look at resources, whether it is performance or space or errors, this is the place. So to efficient processing, you have to minimize as much as possible the shuffling. It is not, you cannot completely avoid it by the nature of how you are doing, unless the data is all sorted here itself. Now I say all deals are coming in the first line only. So you just go here, you don't need any shuffling. So if your data is already sorted, then you can avoid the shuffling. Another example. Or what I want to do, I want to sum of the amounts where each person has. So this is our master. These are our workers. Now this example makes sense to you guys?
Yes, sir, and it's clear.
Sir.
Yeah.
Think about it. See, when I said worker 1 does not have 1 and 2 IDs. See, here we have 4 and 5. Here we have 1 and 2. Here we have 3 and 6. 3 workers. Sum is the function I'm sending to all 3 workers. Now worker 1 will do sum or calculate the do the sum of these amounts for whatever information it has. It has information for 2 IDs and 2 amounts. It will do that sum and then send it to master. Same thing here, same thing here. Now master will just take and sum all of this to get the 1400. So distributed processing is happening here. Got it? Clear?
Yes, sir. Yeah. Good.
You have to
Yes.
very clearly understand when you talk about data frame is not one table or one row. You have to always visualize your data frame is always present on multiple machines. Part of the data frame is on each machine, multiple machines, multiple partitions. Okay? Because how you write code, how you do processing. Okay, right now it is all simplified, but 5, 6 years or 8 years ago, when you're writing the code, you have to always make sure the code runs in parallel in all the machines. You cannot do like in the driver, basically. And there are a lot of memory issues that come up by the way you code. Most of it is now, what you call taken over, improved, better performance, and managed by the platform itself. Okay. So because when I'm doing distributed processing, if I do say, what is the count? Now it will not understand what count are you asking. You're asking the count in worker 1, asking the count in worker 2, or asking the count in worker 3. Which count are you asking? Right? Counter. If I say, do a counter, this machine has 2, this machine has 2, this machine has 2. Which counter you want to ask? Which counter you want to know? So basically, you have to understand single machine processing, sequential processing versus parallel processing. So that is why whenever you're writing the code, always make sure you visualize that your data frame, though it looks like one table, one big row, underlying, it's broken into multiple partitions. The data is on multiple nodes. Whatever you are doing to that data frame is happening parallelly on multiple machines on part of the data of the data frame. Right? Got this clear?
Yes, sir. Yeah.
Okay. Next. This is what is the Apache Spark doing. Underlying. There's a driver program. There's a Spark context, cluster manager, worker node. So this is where your driver program starts. There's a cluster manager. It will assign work to nodes. The executor are created in each of the workers. The task is the lowest level. So each executor, it's like a task is done at the cores. Remember, you have 16 core machine, 8 core machine you are seeing, right? Which means the parallelism will depend on the number of cores you have end of the day. Okay. How many partitions I can do, or how many times I can do a parallel, maximum parallelism can I achieve. I have 2 machines and say each machine is 16 core. How many cores I have total?
32.
32 cores, right? Out of 32 cores, there will be some for managing the operating system, managing network, IO, overhead. So some of the cores will leave. And let's say we take at least 12 cores from each machine, which means they can parallelly work. So task, right? So there can be 12 threads running parallelly on each machine. So it can work parallelly on 12 partitions of data at any given time. Now, if I say I have 100 partitions, so this machine can do 12 partitions, this machine can do 12 partitions, 24. Now, what about other 76? They are enqueued. So as and when the task is completed on the machine, it will pick up the next task. So parallelly, it will happen. But within the parallelism, there is again enqueuing, because you don't know how many, right? So if you have 100 partitions, you cannot bump up to 100 cores. Of course you can. That's what you're doing the elasticity when you want to add more machines. How do you make sure what is the scaling up that you are doing, auto scaling? I have 100 partitions. I have 2 machines, but they are only processing 12, 24 tasks at a time. Now all other 76 tasks are still queuing. Now I can make a decision to wait. Once this round is done, then they take up and do the second round. Or no, I want it urgently. Give me 2 more machines or 3 more machines. So I add 36 more cores. So parallelly now 24 plus 36, 60, 70 tasks are running. So that is your scaling up, right? So that's how auto scaling works. If I have 500 tasks, I keep adding more machines to do all of them in parallel and get it done faster. Or I just say, no, I'm not in a hurry. Take your time. Just use 2 machines. It's not very urgent. Sham tak bhi ho jayega. By the end of the day, I'm good. So it will keep running. Still, there is some parallel processing, but within that, you have enqueued the tasks. Right? So that is how the Spark processing is. Understand?
Yes, sir. Yeah.
And
Yeah.
caching and everything is already in there. It will work when you are processing. So that is the how the tasks, workers, nodes are all connected and are processed. Now coming back, so this concept is clear. Now look at this picture. This is where we are going now. Okay, it looks very complex, but we'll break it down. We will understand what it is doing. End of the day, it should be doing the same thing like this. Okay, just give me 2 minutes. I will be back. Then we can get started with directional acyclic graph, DAG. How Spark processes. What is lazy evaluation? What happens when you do processing? We'll just open the notebook, write code and see how it is generating, how is executing the code when in the distributed processing. Okay. Just give me 2 minutes. Just look at this picture. I will be back. All right, I'm back. So I just went out for some water. Okay. Now let's get back to the computing. I should have started this. Okay, so let's go create compute first. Okay, it will take some time. Meanwhile, we can go and talk about this. So meanwhile, let's talk about lazy evaluation. So you guys know what is lazy evaluation?
No, Harun.
Okay. So whenever you do a command like this, right? When is it executed? When you run it, it gets executed immediately, line by line.
Yes, it will be executed line by line.
Okay. What if I don't do display here? Let me, I think I
Okay.
should start at this. Do we have session expired? Okay. Let me just take this and put it here while that is coming up. Now, what happens if I run this? It will be executed line by line.
Yes, Harun. Yeah. So it creates a data frame.
This is
I
all
mean,
getting connected, man. I don't have serverless here. Oh, okay. This is good. This came up. So we can start. Okay. Now, where is there a Spark job that does run? Do you see anything other than metadata? Did it calculate this? Did it generate the numbers and did it calculate this?
Yes.
Yes. Where? Is there a job? You see how it calculated? Did it trigger a job to calculate that? Now let's say, I want to see what it has done. You're saying it has done. Now show me what you have done. It's like you go in the morning, right? Teacher asked you homework. You have done. Show me the homework. Now you go and start writing in the last bench. Remember? Done anytime?
So the computation is done only when it's asked.
Yeah. This is called lazy evaluation. Okay. Simply like you're playing all the way. You said, yes, it is done. You just say it is done, but it is not done. But you know how to do it. You have looked at it. You know the homework. Oh, I have to just, add these numbers. I know how to do it. I will do it. Then when you ask, have you done it? You say, yes, I have done it. I'm ready. Now, when you say show, that when you go and quickly do the calculation or you start doing the homework. So it's called lazy evaluation. At this point of time, you only have an idea of what to do. Okay, how to do it. You create a graph, you create a sequence of steps. I will take this information, I will multiply with this, I will keep this, and then I will add this. Those are all transformations. You take all the transformations, you build a pipeline, a graph. Once you have that graph figured out, planned, when you do an show, like action, when there is an action, that's when your transformations get executed. Until you have an action, there is no Spark job. See, after you kicked in this, then there is a Spark job. Then it started going back. Okay, what is the first step? Range, get the numbers. What is the second step? Oh, multiply by 5 and then add a new data frame. Now go and show the data frame. That's the job. Okay. Got it? This is called lazy evaluation. Transformations and actions. Where is this? Transformations and actions we talked about here. See, transformations and actions and lazy evaluation. These are the two things, how it creates the graph. Now coming back, let's go and look at the job. This is a whole stage code gen. This is the DAG visualization at each stage. It has collection, RDD. RDD is the basic building block of all of the Apache Spark data frame. It's called resilient distributed data set. We all know what is distributed data set right now, right? We have seen the data set is split into multiple partitions on multiple machines. So it's called a distributed data set. What is resilient? Resilient means when it's broken, it's not lost. You can always rebuild it based on your chain of actions, or it's not actions. Basically, it's chain of transformations. How this data set, how this data frame is being built. How do you get, how did you arrive at this data frame? It is, you go back and see, okay, I have selected columns from this data frame. Now, where is that data frame? How is it built? Oh, it has been built from reading this CSV file. So now you go back, if you want this, you go back all the way, read the CSV file, get this data frame, select these columns from this data frame. Now you get the final data frame. So that is called resilient. And each data frame is immutable. You cannot change anything. Whenever you change something, you get a new data frame object. You're not changing it in place. The old data frame is still there. The data is still there. You're pointing it to the new data. Since there is no variable pointing to the old address data, it will be lost. But that's a different thing. But if you have two different, like here, This is one data frame. This is one data frame. You can have both. Okay. So this is the visualization I'm talking about. Stage 0. What is it doing? Whole stage code gen, where it is doing the execution. This is what it is doing. Simple. One action, one transformation. You're multiplying and then you're getting it. This is the graph. Level 1. We are slowly getting here. So this is the stage 0, whole stage code gen that is done. Now I go here, run this. Same thing, I have this. Now I am doing a repartition. Can you tell me what's happening in repartition?
Doing 7 partitions, 7 sub-partitions, I get, right?
Yeah.
Splitting into.
So it is rearranging the entire data into 7 partitions. Splitting it, now sending it to 7 partitions. Then from there, you're displaying 2. Now, if you look at the job here, now we are getting somewhere. Next step. Stage 2 skipped, stage 3. We know why it skipped, because it's already done in the here, job 1. So first job 1, it's taking this exchange, repartition, job 2. So don't worry about how many jobs it is creating. Just focus on this graph, how it is going. So ignore for skipped right now. Let's just look at the whole picture. Because it is doing, I have done it earlier. I don't need to do this again. Skip here from job 1. You combine job 1, job 2. It's just like a duplication. It's just showing it here what it was done in the job 1, step by step. Exchange. Exchange, whenever you do, is your shuffle. We talked about shuffling, right? So when you do repartition, it's kind of moving data into different nodes or same machine, but multiple chunks, multiple partitions. That's what it says, shuffle query. Whenever there is a shuffle, there is a stage. Stage 1, stage 2, stage 3. So if you want to go represent here, stage 0, stage 1. So whenever there is exchange here, this is stage 1. This is, say, from here, it is going here, exchange, stage 2. So this is a different thing. We will come here. So let's look at, whenever there is exchange, means there is a shuffle. There is a new stage boundary that is drawn. Remember, shuffle, stage, exchange, these 3 together. Whenever there is a exchange, which means the data is being shuffled, there is a new, here. Stage, there is a new stage. Fine. So now it is repartition. Now let's go here. Now I am taking 2 data frames, not 1. This is 1 data frame. This is 1 data frame. I am repartitioning the 1 data frame into 7 repartitions and repartitioning the second data frame to 9 partitions. Okay. Now I'm creating another data frame, taking this df3 and multiplying this. This is the function that we used. Then join. I'm joining this data frame to this data frame. Then I'm saying sum, take this data frame and just doing a sum of all the IDs. Then show. Got all of this? So tell me, where is the action in this?
Actions.
Some
Show.
show. Some show.
Sure.
Some show.
Okay. Sure, everybody?
I mean,
Yeah, okay. Simple. Wherever you think is action, you comment out and see if anything is happening or not.
Even the multiplication also is an action only.
Yeah.
DF5.
It is an action. Even this is also action. It has to generate. Action is not something like, literally doing something. It knows it has to do something. Okay. For everything, it has to do something, but it's just planning when to do. Okay. So there is some work to be done here. If you say action, there is work here. There is work here. There is work here. There is work here, here, and here, and here. All of this, there is some work to be done. But when it will be done? Only when you say, show me your work. These are actions. So go and check what are transformations, what are actions. Actions are mainly like you do like any aggregations, you write to database, you display, you collect. All of these are actions. Okay. Now let's look at this. Oh, now we are coming here. And to talk about this, what's happening in this DAG? Directional acyclic graph. Directional is because it always moves from left to right. You cannot come back. It doesn't flow anything back. Okay, it's only in one direction. Acyclic is, it's not going in endless loop. It's not a loop. It's in one direction. Graph, cyclic graph. Okay, let's talk about this. All skipped means it is actually done in the previous step. What is this first one? Is doing this range, right? 1 to whatever 1 million. Stage 13, what is this?
Next party. I mean data frame, DF2.
Yeah, this range. Okay. Stage 14,
DF.
I think it's part
is exchange here.
exchange new party.
Which is this one. And then there is a whole stage code gen. Right? You can look at these each stage, but that's okay. I don't need to. These are skipped stages. Okay. So here there is multiplication of DF5. So DF5 is coming from, so DF3 you are multiplying, adding whatever is there in DF3. DF3 is repartition from DF1. So this one. So whatever you have done this is coming here, and this whole stage code gen is your multiplication here. Correct?
Yeah, DF5, yes.
Yeah. Then there is this exchange and this exchange together. The next is join. So when you are joining, there is a shuffle of data. When there is repartition, there is shuffle. When there is join, there is shuffle. These are the two important places where shuffle happens. And joins are very particularly you have to look at, because if you write bad join, it's gonna shuffle the entire data all over the place and you get out of memory errors and all of that. Anyways, fortunately, right now it is all taken care of by the platform. But earlier, this was the most complex thing or the focused thing when you write code, how you are doing your joins, which join are you doing, and how you are making sure there are no memory errors or no network IO to shooting up. The data is moving all over the place between the machines. So that was one area where you had to put a lot of focus on. I mean, luckily right now it is all handled. You have adaptive query execution, AQE engine, with the Spark that comes now. So that will take care of all of this. Or in the runtime, it will make sure it will see what is the data, how many rows, which is big table, small table. We will cover that tomorrow. What is a join strategy? How does Spark use join strategies when it joins two tables? There are 2 or 3 join strategies that we will discuss tomorrow. Okay. But for now, yes, see why we have to check that, because whenever there is a join, there is a shuffle data. Okay. So before that, you shuffle the data, you sort, because you have to join, right? So before joining, you do some sort so that all the keys are sorted. Then you can join these two tables easily. Okay. People who have not have SQL experience, please read about joins in SQL. Very, very important. The most important thing. How do you join with keys and all of that? What is a join and how do you join with keys? So you do a sort on both data sets and you join. Okay. Once you join, again, there is a shuffle to take everything into one. And then there is a sum. Sum is just because you don't need to shuffle it all in one thing. So once you shuffle and have everything in one place, all joined data, you just do the sum. This is the whole stage code gen that is happening here. Now this makes sense. It's not confusing anymore, right?
Yeah.
Guys, Venkat,
Yes, understanding.
Yes, sir.
Venkat, Sai,
Yeah, I'm getting it. Yeah.
okay. Kiran, how does this look?
Yeah, I mean, thank you. It's clear, Arun.
Right? Yeah. So,
Yeah.
once suddenly we look at this, it looked like, maze. What is all of this, right? Now broken down into pieces, it's all very, very simple. Whatever is their action, it's trying to put it in a graph. Okay. Now think
So
about
practically, Arun, so in real time, so why we need to understand? So when we are writing some queries, we need to understand, write the queries accordingly, or what is the use of this one to know all these things? Because these are things are happening in the back end, right? It's not coming in the
2 things. First, you have to understand how it is working. 2, from the perspective of interviews. They can ask you what is DAG. So you have to explain, or they have to ask you, they can ask you about shuffle. They can ask you about stage, or they can say, tell me how DAG works. Do you know how DAG works? Right? If you are able to explain this step by step, you will be very impressed. Okay, what is, you have to start with, you have to build your story. Okay, when I'm writing a program, I know Spark is lazy evaluation. By lazy evaluation, I mean it'll have transformations and actions. Whatever transformation I do, when I call the action, those transformations are executed. How they are executed? Based on a DAG. It's called directional acyclic graph, which Spark creates, reading all the transformations. And when you call the action, it executes all those transformations based on the DAG. Now at each after the transformation, if there is a shuffle, like if I do repartition, if I join, there is a shuffle because the data has to move across. So when the data is moving across, there is a shuffle. So each time there is a shuffle, there is a new stage that is created. That's why in the DAG, you see multiple stages. Now, once that is shuffled, and then you do joins and you get everything into one place, then there is, when you actually there is a join, you have sorting and merging the data. Then Spark also applies join strategies to make sure which strategy it has to use to do the join efficiently. Once that is done, you have the final data set. Then you get the entire data out as a data frame, process data frame. So this is how you have to explain so that they know you understand the concept, not just writing the code in a notebook. Anybody can write the code book, right? You just ask, they will write a notebook. But when you ask a question, how it is working, you should be able to explain. Because this is the basic foundation how the Spark was invented and right processing, right? So from that perspective, you should know what is under the hood. How is it working? That's the whole purpose first. Second, you don't have to write the code looking at this. As you said, you're right. It is executed in the backend. It will create. This is for Spark to use, not for us to use. We are here only to understand. When there is some issue, okay, you can go and look at these things and see. Basically, when I said, right, we talked about, hey, this guy is taking, I am expecting everything to be done by 12:30. This guy is giving me 12:30. This guy is giving me 12:30. Why are you taking till 1:20, man? You know, you are slow or you are not working. That's not true, right? Because I have more data to process, right? Now, let's say in this example, instead of 500, okay, instead of 100 homes, I have 1,000 homes. And when I'm distributing, I am very partial to these two guys. I'm only, these are my brother-in-law, so I give only 30 to them. 150 homes, 300, and then I give 700 homes to this guy. Okay. Now what happens? Oh, what happened? Now what happens?
It takes more.
Take more time, right?
Yeah.
700.
This guy will go and say, he is night 6 o'clock, 8 o'clock, 9 p.m. He's still working.
Yes.
Okay. Because I don't like this guy, I gave this to him. Now these guys say, oh, we have finished by 12:30. We are very efficient. We are done. Now, why we are saying the job is not finished, right? The report is not done yet. Those two guys have completed and sitting there, but I didn't get the report because I don't have all the information to make the report. I have to wait for this guy to finish, and he is taking ages. Now, when I go and see why you're taking ages, that is when I realize, oh, you have 700 homes. Who gave you 700? Why did you get 700? This is because uneven partitioning, right? Uneven data. I'm distributed unevenly. There are only 30 here, the 150 here, and I've given 700 here. So this is uneven partitioning. This is called data skew. Okay. You have to use these terms, data skew. This is very, very important thing. Because in interviews, if you throw the terms like this, I'll tell you, they'll be very impressed. These are the things that people don't know. When you said, right, why we need to know all of this? I just write the code. Where you differentiate, how do they know that you really know your job is when you start using these things like shuffle, like network IO, like data skew, right? You have to start using these terms so that they know, oh, these guys know what they're doing. They actually worked on all of these things. How do you solve data skew? It's called salting. Okay. I mean, most of them may not be relevant today. As I said, the machine, the kind of the platform takes care of you, but you have to solve, data skew. So this, how does this come like 700? Okay. So let's say I am distributing this by names, 150, 700. Okay. Let's say, hey, name starting from A to M you take. Okay. Name starting from N to Q you take. Name starting from R to Z you take. Suppose in that village, everybody's name is starting with R and S. Most of them. Then unintentionally, he is getting more work, right? When you do that partitioning.
Yes.
Right. So that is how the data skew happens. Data skew happens because when you are assigning, joining the keys, some keys might have more data than the others. Okay. A more practical example is if you're joining data, say, by state in India. Now, if I have two states like Kerala and UP, the state having UP will have, the key having UP will have more data who's processing for that state. The state having the key to join with Kerala have less data. So that is the data skew. How do I solve that? By using a technique called salting, which means we will not use like this. We will introduce some more characters in this so that ideally everything is distributed. Okay. So we can say A to M plus in street 1 to 10. Something like that. Okay. It's not be correct, but I'm just saying. You do salting, you change the keys so that they get evenly distributed, not just with the state. Okay. I will say state plus age. Then even in UP and Kerala, you get both state code plus age, then you get evenly distributed. So yeah, to answer your question, yeah, no, we don't need to know how it is processing, but it's better to know. It's good to know how all of this happens.
Also, Arun, so this distribution is, I mean, it's doing by some application manager or some load balancer kind of stuff.
It has its own algorithm when it does the partition. It's mostly, you can say, arbitrarily it distributes. By default, when you read, there is a default partition of 200. So it arbitrarily just distributes the partitions. Now you can go back and say repartition. Okay, you can look at how many partitions it has. When you write the data, it will show if I'm getting 0 bytes files. Right? So there is no data in that. Now what I can do, don't do 200, repartition to 10, which means the output I will get only in 10 files. Coalesce, can do coalesce. Coalesce, we will talk about it, to reduce the partitions. Okay. So all smaller partitions or 0 partitions, they get removed, because if there is a partition, there is a task that is generated and then it does nothing. Okay. It triggers the job, it goes there. Oh, there is no data. I'm happy. It will come back. Okay. My job is done. Right. Very, very happy. I have done the job. I have done 30 jobs, but when you go and see, half of it, there is no data. So he didn't have to do anything. Just put a tick mark, done. That's it. Right. So those things to avoid, there is still network IO processing that is happening, because to run the task, right, it has to start the thread, go look at the data and see there is no data, come back, close. There is IO happening. All that is waste. So for that, you do repartition or coalesce, so that you take smaller partitions. So now idle jobs are not generated. So you're saving time on all of that.
So in that case, in the earlier example, Arun, so you said the node 3 is having the more requests, right? Some 100. So if that is the case, then we will see that one, okay, this node has some 700 requests are coming. I mean, it has the more requests are there. So we can do the repartition and it will distribute accordingly.
Yeah.
We need to do some manual job.
So here we have 3 partitions, right? You can do repartition to 10. So you get 10 partitions, then you get data distributed in 10 partitions. Now, who is processing those 10 partitions is different case. So those 10 partitions might be again on 3 machines only, then it will go sequentially. First we will do 1 partition, but at least all 3 machines will have some more partitions. Ideally. The work is distributed evenly, more or less. Okay, and you can also do partition by keys, basically. So if I have some key, okay, do repartition by this key also you can mention. So it will sort based on that key, create chunks and then do partitions based on that, so that you can do sorting. Similar keys are there in the same partitions. It all will help in performance.
And also I hear the partitions are 2 types, right? One is static and dynamic partition. Is it any like that, or
No, dynamic partitioning is yeah. So those concepts, if you say, basically, you are creating the partitions initially based on the date, for example. So each day is you have a partition that is the partition, the name is same, but the context is different. So what you're talking about, those partitions, is from the storage perspective, how I am storing in the partitions, like Hive used to have that. Partition means different in different contexts, right? Even Oracle, those also have partitions, sharding and all of that. So here, static partitions is, suppose I want to store the data by date or by department or by state. Those are static partitions because states don't get created on a daily basis. So you have 50 states in US, you have 50 partitions, that's it. Whatever data is coming in will go into those partitions too when you are storing, when you are saving. That's one concept. Dynamic partitions, on the other hand, you say I want to create partition every 1 hour. Okay. So for last 1 hour of data, a partition is created and it's stored. Next 1 hour, it's creating a new partition, which is dynamic. So that is the context of static and dynamic partition. Now, again, another question is, what do you consider when you do a partition? Cardinality. So you don't do partition on high cardinality. The items like date of birth or your date of birth is fine. Maximum you'll have, no, date of birth is one cardinality. Employee ID is one cardinality. You don't want to do, because every ID is a new partition, it's a new ID as long as you're getting an update. So you'll get generated millions of partitions, which again processing will become difficult. So you have to make a judgment of making a partition on the low cardinality. Again, this is from the saving of the data perspective. Low cardinality, as I said, like, number of states or countries or departments, HR, finance, sales. So something like this, where there are specific set of chunks or partitions that you can create. So you have to create partitions based on that. Again, within those, sometimes you might add a new department. That is fine once in a while. Sometimes you get new states created. That is fine. But they don't get created on a daily basis, right? So that is low cardinality. You create partitions based on the low cardinality. Okay. Now partition, that's it. Dynamic and static. So dynamic partitions basically is when you want to create on the fly, when the job is running based on the data that it is processing, the partitions get created. Okay. But again, those was in the days of Hive processing, like you had creating files, folder structures in Hive based on the partitions, how you easily access the data based on partition. When you do where clause, it skips the partitions. The same thing now Spark also does, but it takes care of using the Delta, right? So we have seen in Delta, it creates the statistics, max, min, files based on your transaction. So it just scans the metadata in the transaction log, and it skips some of the files, some of the partitions when you actually want to read the data. So it's the same thing. Even in Spark also, you can do partitions, and when you're writing to the files. So these partitions get written, but when you're writing, also you can do repartition and write. So basically it will write those partitions. So it will be faster when you read. It can skip the entire partition based on what you are reading. Okay.
Yeah, good.
Does that answer your question?
Yeah, I'm good. Yeah, thank you.
So I'm repeating this again and again. Please go back this video, watch multiple times, make yourself comfortable with these terms. Okay, lazy evaluation, transformation, action, DAG. Okay, what is DAG? Shuffling. Okay, partitioning, stage, where a stage is created, sorting, joins. Okay, data skew. salting. These terms get more and more comfortable with this, and be comfortable to throw around these terms. But just don't throw around, because sometimes if somebody wants to pick you, he can get deeper into those questions. But make sure you understand, you're prepared, and then you can lead. When you are in an interview, you can lead them here. If there is some fancy term which you know about, okay, and then you throw it. Sometimes if they catch that bait, they want to ask more questions on that, and when you're prepared, it's like you are impressing him. Okay, but sometimes it may also backfire. So make sure whatever terms you are throwing, you are prepared. Okay, but these are very good fundamental concepts. When you go, they will know, okay, not everybody know all of this, how this works. Okay, so you see here AQE. This also we will talk. Adaptive query execution tomorrow, and the join strategies. So I will talk about when you run any of this action or query, how that is processed again. So this is a processed. There are multiple stages of processing. Now we looked at how at level 1, how these are planned and executed. Now you see here, I only wrote whole stage code gen or query, right? But what is happening inside this whole stage code gen? How is this actually executed on the platform, or how is it reading the file? How is it doing this join? How is the the query plans in Oracle, SQL, wherever you must have done? You look at the query plan, physical plan, virtual plan, actual plan, what is the cost based on the plan, whether it is reading the whole table or whether it is reading the index, that is scanning the whole table, it is only reading index and skipping. All of that we will see, whether we are joining all the keys or not, whether it is a whole table scan is happening, whether we are doing a join first and filter later. All of that is again a process, level 2 of how it is executed. All of this, it will calculate before execution of that query. When you write a join and then do a select from this table, join this and get the data, what is exactly happening? How is it planning that query? How is it executing that query? What are different stages that we will talk about? So this is, can say whatever we have discussed today is level 1, we'll get into level 2, deeper, into the next level, and we'll uncover what is adaptive query execution, what are the different stages basically when it executes a query, how does it read, what are the join strategies it uses. It's just joining these two tables. What if the tables are very huge and then millions of records? How does it handle? What are the strategies and what are the caching strategies? So remind me tomorrow if I forget. We want to talk about the query execution, and we want to talk about join strategies, and we also want to talk about caching. These 3 things. Okay, then that will wrap up our fundamentals. Any questions? How does this sound? How does this look?
Yeah, it's good, Arun. I want to check this once again.
Yeah. Telling you, for the interview perspective, this is very important. Okay. Understand this.
Arun, did you saw the message that Murali kept in WhatsApp?
Yeah, I saw, but I couldn't get to it.
Will describe history command will work in Unity catalog also?
Yeah. We talked about it, no? Describe extended. So that's more
Okay.
because it was like Delta live tables.
Okay.
Yeah, it's different. It's Delta table, but it's different. It's managed by, it's a live table, Delta live table. Sometimes it is created as a materialized view instead of table.
Okay.
Okay. We will check that also. We'll have one session, working session. So most likely we'll be wrapping up in next 2 weeks. As I said, this week and another 2 weeks. And then we can plan for certifications. after the next week. Okay.
Okay. Yeah.
All right, guys, we are close. Anything else you want to talk about? Any questions, concerns? All good? Please go through this recording again, understand, run this. It's simple. You can also see this and parallelly go and do some reading, what all of this means. There are a lot of examples on in the internet. Even Medium, there are some examples about Spark internals, Spark DAG, and all of that. So apart from this slide, you have multiple things here. You can see what are the different stages. Okay, and each stage, what is happening, you can see here. Spark range, split times 5, all of this. Duration, if you see here, how much time each stage is taking. This is something I told you, right? You have to look at. So this is taking 13 seconds. This is taking only 0.1 second. When there is too much of data, too much calculations, processing, the time here will be more. Shuffle read. This is something that you also have to check. When tomorrow we'll also talk about the shuffle more. We are doing cache and spill to disk and all that. So how much data is being shuffled? Okay. So the more shuffle read, shuffle write, the more complexity. Shuffle write means it's writing to the disk and it is shuffling. This should be minimum. We should minimize that, or at least we should be able to talk about that. This is look at storage, environment, executors. So how many executors you have? So it's a single node only driver. If you have multiple nodes, all your executors will show up here. How many executors you are using? Say 8 cores. How many cores you are using? How many tasks it is completed? How much total time it has taken? How much total shuffle read, shuffle write? So if these two are matching or not, whatever it is writing, almost it's reading. All the information is there in the UI. So if you look at SQL and data frame, so what are your data frames here? You can go here and see simple numbers. This is the data frame. This is another data frame. Okay. So all of this you can see here. Queries. Streaming, if you have, you'll see here. This is just JDBC, ODBC. That's fine. Okay, these are the important things. Read about it, go through it, be comfortable with the concepts. All right, anything else? Right, all good?
Yeah.
Yeah.
Yeah. Good. Thanks.
All right, man. Take care. Have a good day. We'll meet again tomorrow. Okay.
Thank you, Arun.
Arun, can you share that videos and that dumps for the certification?
Yeah,
Can you
yeah.
put it in
Yeah.
the WhatsApp group or someplace?
Yeah, I don't see the problem is I don't want you to focus solely on that. That's why I'm not sharing. It's not something that I have. It's everything on the internet. It's on the YouTube. But
Okay.
if I just give you that, I don't want people to think that, okay, that is just enough. We'll go through that and then give certifications. So I'm just waiting for you to go through this training first, practice, and then whatever documentation or the documents that Srini has shared, at least go through it, understand the concept. See, doing certification is not a big deal. If you want to do in a couple of days also, you can do. So the information is everywhere. It's not something that I have. I don't want to share with you. Nothing. It's just on the YouTube. Same. Even if you search, you will get it. But I don't want to just misguide you. Thinking just if you do this, certification is done. That will defeat the purpose. But I will share it anyways. For the both for professional and as well as the associate. I think about three videos. Go through that. That will also give you some. But when you go through that, once you have completed all of this, you will have more, you can understand more, connect to it. Okay, I will share that, no worries. But
Yeah.
please make sure you go through all the content and practice first. Okay.
Yeah.
All right, guys, take care. Have a good day. Meet you tomorrow again.
Thank you.
Thank you.